Hi there, and thank you so much for joining me again for the second part of my lecture series on reliability, right? So you probably remember from part one or the previous video that reliability refers to consistency of measurement, right? So if my measurement instrument for the particular construct I'm attempting to measure is reliable, okay, then that means I should get, or my respondent should get the same score no matter how many times they take my test, or no matter how many times I attempt to measure the construct, right? So we discussed that in my last video, and we also talked extensively about different sources of measurement error that impact reliability. So we talked about unsystematic or random error, which is just due to extemporaneous or chance factors. And we also talked about systematic error or bias. Okay, so unsystematic or random error always changes our obtained score unpredictably, right? So it could either increase the score for one measure and decrease it the next, right? So it's random and unpredictable, whereas with systematic measurement error, it's always either increasing or decreasing. It doesn't change, right? So unsystematic error or bias, right? If it were a scale, we would always see, if we set our scale to be 5 pounds more than our actual weight, it would always be increasing. And if we set our watch behind by 5 minutes, it would always, the obtained score would always be 5 minutes faster than, or 5 minutes before the true score, which is the actual time, right? So what are we going to talk about for this video? Well, we are going to talk about ways to reduce or eliminate measurement error and therefore attempt to have an obtained score that better approximates the true score. So let's go ahead and jump right into it. Okay, so again, by way of review, for any measurement instrument that we are creating, our score on that instrument is going to be our obtained score. Whether it's a questionnaire looking at levels of depression, whether it's an intelligence test, whether it's the self-concept clarity scale that we talked about last week, doesn't matter what type of instrument we're using, the obtained score is a product or the addition of the true score plus error. So the true score is our respondent's actual measurement or actual degree of whatever we're measuring, right? So their actual depression score or their actual intelligence score plus error, which we've already talked about. So what is our goal here when we are attempting to create a reliable measurement instrument? Well, if the obtained score is the true score plus error, right? If our source of error is, or if our error term is very large and random or something that fluctuates, then sometimes you might get a very high score and sometimes you might get a very low score. So if you sometimes get a very high score and you sometimes get a very low score, this means that your measurement instrument or your test is going to produce a very different score each time you give it, even if you give it to the same person, right? So that means that your test or your measurement instrument is going to have very, very low reliability. Okay, so if we want to a reliable test, we want to minimize or reduce the error term so that our obtained score is a better estimate or a better approximation of the true score. Okay, so how do you determine if your measure is reliable? Okay, well, one of the easiest ways you can do this is by looking at test-retest reliability, right? So we could give the same test to the same sample of respondents at 2 different times, okay? So maybe we administer the first test in April, okay? That's the first test administration. And then the second one, or excuse me, the first time our respondents take the test is in February, and then they take exactly the same test in April. Okay. So again, we give the same test to the same sample at 2 different times, February and April, and then what we're going to do is we're going to calculate the correlation between the test scores from our sample at time 1 or in February and our respondent scores on the test at time 2 or in April, right? So that our symbol is again the statistical symbol, the Pearson R, which reflects again the quantitative relationship between or the numerical relationship between the scores at time 1 and the scores at time 2. And we're making a number of assumptions here, right? One of the key assumptions whenever we do test-retest reliability is the assumption is that we are measuring a trait, not a state, okay? So another word for trait is that it's a fixed construct, okay? So when we're dealing with traits or fixed constructs, we're talking about things like personality inventories, so extroversion, introversion. We're talking about intelligence, right? So intelligence, at least the way that it's measured by psychologists, is a fixed construct. So it's not a function of learning or experience, but rather a function of innate or fixed or unchanging qualities within the individual as it relates to cognition. So your general thinking and reasoning abilities. Whereas a state or variable construct is going to fluctuate depending upon the situation. Okay, so whenever we attempt to assess our measurement instrument's reliability with test-retest, we're assuming we have a fixed construct or a trait. And our other assumption is that there should be a direct relationship, right? So if you score high, if you have a high score in February, you should also have a high score on the test in April, okay? So if you score high at time 1, you should score high at time 2, right? And so we assume then that there should be a high positive correlation so that your score at time 1 predicts or is associated with your score at time 2, okay? Whereas if you obtain a low correlation or your R value is very small, okay, then it doesn't, okay? So again, we are assuming that there is a high correlation or a large R value between time 1 and time 2 if your measurement instrument is reliable. And if there's a low correlation and time 1 doesn't predict time 2, then your test isn't reliable. Okay, so what are some factors that influence test-retest reliability? And how might the time interval between administrations of the same test affect the obtained score? Okay, well, we know that there are going to be time sampling error factors anytime we administer the same test, right? And those factors are going to include individual participants, whether they're hungry, fatigued, in a bad mood, right? Just like I showed you with the example of taking an exam right after you break up with your significant other, right? Obviously, those are going to change your obtained score, presumably with a decreased score on your exam. So those are individual chance factors. There's also environmental chance factors or test administration, right? So if the person administering the test is rude, or if you're in a very hot, uncomfortable space while you're taking the test, those could all influence your obtained score. The time interval between administrations of the same test is also important to consider, right? Because if I administer an intelligence test on Wednesday at 3 p.m., and then I administer the same exact test on Thursday at 3 p.m., right? That's a very, very short time interval of only 24 hours, right? So I would expect that some of the questions are still going to look familiar to my respondents, okay? So they're still going to remember the question, and that's going to help them, right? Or that's going to increase their obtained score. And even if if they have to use a particular skill set, right? So if they have to maybe rotate shapes in their head or other things they might have to do on an intelligence test, having practiced the same procedure the previous day, right? That's obviously going to increase their score as well. So if the time interval is too short, we would expect the obtained score to increase due to practice and memory effects. Whereas if the interval between time 1 and time 2 is too long, their true score might actually change, right? So they might have gains in terms of whatever construct you're trying to measure, right? So for example, if I was giving students a general psychology aptitude test, which they are definitely out there, right? So if I administered my first test at the beginning of Psych 101 and my second test at the end of your senior seminar, your last psychology course, then obviously we would expect your true score to have changed dramatically as a function of your experience, right? So these are all things that we should be aware of when using the test-retest method of assessing reliability. Okay, so another alternative we could use if we're trying to eliminate those time sampling errors and also the issue of time interval is we could use alternate forms reliability, also referred to as parallel forms. So with this particular assessment of reliability, what we would do is we would give one sample of people two different versions of a test at one time, right? So we would give them version A and version B, okay? And then we would calculate the correlation between their scores on version A and their scores on version B, right? And our fundamental assumption is that if our respondent scores high on version A, right? If version A is testing the same thing as version B, then they should also score high on version B. So the primary advantage of alternate forms or parallel forms reliability is that we eliminate that time sampling error, right? So because everyone takes both versions, right, together, then it means they're in the same state for both versions. But there are some things that we have to be aware of. So for example, because we are creating two different versions of the test, we have to be aware of content sampling error. So remember, content sampling error happens when the particular subset of questions that we've chosen for a test, because of those specific questions, cause an increase or decrease in our obtained score, right? So we really have to think hard about what questions go on version B and what questions go on version A to make sure that they're comparable to each other, right? So when I first introduced content sampling error in my first video, I gave you the example of an intelligence test, right, which has both a verbal component and a quantitative component, right? And I showed you basically a bunch of different words, and some of those words were common, and some of those words were uncommon, and some of those words were extremely rare, right? So what we would want to do is to make sure that we have the same number of rare words on each version, the same number of uncommon words, and the same number of common words. And we would also want to pay attention to not just how long the words are, but also the connotation, right? So for example, both tired and bored are short words that have kind of a negative connotation associated with them. So essentially, we want to make sure that all of the dimensions, if you will, or qualities of the items or questions that we choose are the same across both forms of our test. Okay? But we also have a couple of other options as far as assessing the reliability or consistency of our test. So another option that we have is something called split half reliability. So with split half reliability, you only give one test to your sample, okay, rather than two. And what you do is you split the items or the questions on the test into two groups, or you essentially split them in half. So you have one sample of questions on the test. So you have one sample consisting of, for example, if you have 50 questions on your test, you would split them in half into two groups of 25 questions, okay? And then you would calculate the correlation between the first half of the test and the second half, okay? So for example, if the assumptions that we're making are if our respondent gets a high score on the first half, right? So if they get a high score on the first 25 questions, they should also get a high score on the second half of the questions, okay? And split half reliability relates to a way of measuring reliability that's called, or a type of reliability that's called internal consistency. Okay. So as I mentioned last week when we talked about surveys, a lot of times for psychological constructs, you can't measure them directly, right? So instead, particularly when using self-report, we often like to have several related questions under the assumption that we'll get a more accurate result that way, right? So when we looked at, for example, self-concept clarity, all of the questions on the self-concept clarity scale are essentially asking the same thing, which is, are you consistent and confident in your appraisal of yourself, right? But there are multiple ways we can ask that question, right? And the reason why we want to have multiple questions assessing the same construct is if we only had one question, it's possible that our respondent might not understand the question, okay? So their response to that one question wouldn't be an accurate representation of their true score on that construct, but rather it would be a function of error, which in this case reflects the individual's lack of understanding, right? Okay, so, but one of the important things that we have to do when we create a scale to measure something like depression or self-concept clarity is we want to make sure that all of our questions that we have, okay, are measuring or are getting a response from our respondent that relates to the same dimension. Okay, so what do I mean here? So let's say that you're a clinical psychologist and you are interested in developing a new scale for depression or a new questionnaire that measures, it's kind of a global measurement instrument for depression. In order for this depression scale to be reliable, we would expect if we have a bunch of different questions that are all meant to assess depression, right? Then we would expect our client or whoever we're giving the questionnaire to respond to each of our questions on the scale in a similar or consistent fashion, right? So, for example, if you expressed strong disagreement, or your client expressed strong agreement, excuse me. So, if your client expressed strong agreement with statements like "I am sad" or "I feel hopeless," okay, then we would expect them to express strong disagreement with a statement like "I am generally satisfied with life," right? So again, it's not so much that they have to give the same responses literally, but rather, depending upon the nature of the question, if we're adequately measuring depression, then it would mean that their responses should be predictable or similar or consistent. Another example is if we are developing a questionnaire looking at bicycle, how much people like bicycles, right? If a respondent expressed agreement with a statement like, "I like to ride bicycles and I've enjoyed riding bicycles in the past," and disagreement with a statement like, "I hate bicycles," this would be a good indication of the fact that our test is internally consistent, or it would suggest that our test has a high level of internal consistency, right? Because those responses are very predictive of someone who would score highly on our trait, just like expressing agreement with statements like "I am sad, I feel hopeless," and disagreement with statements like "I am generally satisfied with life," would indicate that someone scores highly on our trait. If they were to respond similarly to all of those questions on our construct, then we would say that the test is internally consistent. Right? So again, we would not want to include items in our scale that do not assess the same variable or construct, or we would not want to include questions that our clients respond to differently than other items on the scale. Okay, so we want our respondents to, their answers to the questions to be predictable, depending on whether they have a high or low uh, um, level of whatever the construct we're trying to measure is. Okay, so there are two measures of internal consistency, or two ways of determining whether the questions we have chosen to measure our construct are reliable or not. Okay, like I said, there's the split halves test, which randomly split. So the procedure for the split halves test, right, is you administer your test. It's one test, and all the individuals in your sample complete the test. And then when they hand the test back to you, let's say it has 50 questions, you split the answers to those questions, or you split those questions into two halves of the test, right? So the first half is the first 25 questions. The second half is the second 25 questions, right? And then you look at the correlation between the first half of the test and the second half of the test. And our assumption is that if all the questions are measuring the same thing, the same construct, then there should be a strong positive correlation between your participants' responses on the first half and their responses on the second half. Okay, another way that we can measure internal consistency, or another way that we can determine that the questions that we've chosen for our test are all measuring the same construct, is we can compute a statistical index called Cronbach's alpha. So what Cronbach's alpha does is it computes the correlation between all of the responses to all of the items in the scale. So if our depression scale has 30 questions, okay, Cronbach's alpha is going to look at the relationship between all of those questions to see if they're, like I said, if they're related to each other. And it will also calculate how alpha will change, or how our correlation will change if we delete an item. Okay, so the way that we interpret Cronbach's alpha is that a correlation, or an alpha value of 0.70, okay, is going to indicate high levels of reliability, or good reliability, okay? So 0.70 or higher is going to indicate good reliability, okay? But sometimes what happens when we're evaluating internal consistency with Cronbach's alpha is, let's say you get an alpha value of 0.40, but then you notice that there's a particular question that participants are responding to in a slightly different way as compared to the other questions. One of the neat things about Cronbach's alpha is you can also calculate how alpha will change if you delete one of the questions on the scale. Okay, so this is all done electronically with things like SPSS. So SPSS is the statistics package that we're going to be working with later in the semester. But you can get a value of alpha that will tell you essentially what your Cronbach's alpha, or measurement of internal consistency, will be if you drop one of your questions. Right? So let's say initially your Cronbach's alpha is at 0.40, but as soon as you remove a question, it shoots up to 0.80, right? What that suggests is that question isn't measuring the same construct as the other questions are, and so it should be removed, okay? Okay, so let's go back to the first measure of internal consistency that we talked about, which is split half reliability. So when I gave you my earlier example, I said the easiest way to do a split half reliability test is simply to correlate the first set of questions, or the top half, with the bottom half, right? But let's suppose that you are looking at a personality test that is supposed to tell you whether your respondent is an extrovert or an introvert, okay? And you notice that for the first 10 questions, or for the top half of the test, right? Your respondent is giving answers that are highly consistent. Okay, so you'll notice in the red section here that he's giving a lot of 3s, 4s, and 5s, right? So presumably he's expressing strong agreement with statements like, I enjoy being around other people. I'm not intimidated to go to a party where there's a lot of people I don't know, right? So his responses are highly consistent, and they lead you to believe that this respondent is an extrovert, okay? Because again, they're responding in the same way to all of the questions, right? But then something interesting happens when you get to the bottom half of the questions. And suddenly their responses become much less consistent and much more random, right? So we've got a few 3s and 4s, but we've also got 1s and 2s, right? So things are getting a lot less consistent. So that could mean that you've got some questions on your personality inventory scale that are not good indicators, right? Or that are not consistent with your other questions, right? But there also could be other things going on, right? So let's imagine that you have not 20 questions on your personality test, you've got 200. Or excuse me, let's say you've got 400, right? So for the first 200 questions, your respondent is awake and alert and motivated and is carefully reading the questions and selecting his responses. But after 200 questions, your respondent is understandably fatigued and just starts circling random responses, right? Well, in that case, you don't know, once you correlate the responses from the top half with the responses from the bottom half, right? If you get a low correlation, okay, you don't know if it's because your questions are not internally consistent, or if it's due to something about your respondent, right? So said differently, you don't know whether there's a low correlation between the questions at the beginning of the survey and the questions near the end of the survey. And you don't know if it's because the questions on the second half of the survey are different than the questions on the first half and therefore aren't measuring the same construct, or whether it's something going on with your participant. Okay? So how do we fix that? Well, one thing we could do is we could, instead of splitting our responses and looking at the top half versus the bottom half, or looking at questions 1 through 200 and then questions 201 through 400, okay, we could just do a random sample, okay? So we just randomly choose the questions in red here to go in our first half, okay? And then randomly choose another selection of questions to go in our bottom half, right? So we've got half the questions that we randomly selected for the first half and half the other remaining questions for the second half, okay? What that would do is it would mean we've got fatigue affecting people's responses in both halves, okay? Or we've got fatigue still affecting people's responses, okay? But it's affecting both halves comparably, right? We don't have no fatigue in the first half and all the fatigue in the second half, right? The effects of fatigue are evenly distributed for both halves of the questions, right? If at that point we get a strong correlation between half one and half two, right, then that should give us a good indication that our scale or our measurement, the questions on our questionnaire are highly consistent, right? But our selection of questions, right, is kind of random. We just kind of haphazardly decided what questions are going to go in the first half and what questions are going to go in the second half, right? So maybe we want to do it a little bit less randomly, right? So if that's the case, we could take all of the odd or even numbered questions and put them in the first half, and all of the odd or even questions and put them in the second half, right? So let's say we chose all of the odd numbered questions for half one and all of the even numbered questions for half two, right? In this case, we're going to see the effects of fatigue in both halves, right? Because we have some questions in half one that were numbered 200 or 400 or 350, and some questions in half one that were like 1, 2, or 3, right? So we've got some questions that were subject to fatigue in half one and some that weren't in half one, and the exact same for half two. Some of the questions that were near the end and some of the questions that were near the beginning, right? So we've got that, but if we were to use odds and evens, then our split for the questions isn't necessarily going to be susceptible to potentially odd or strange random divisions, right? It's a little bit more systematic to just go odds versus evens, right? Okay. So another type of, another index of reliability, particularly when you are conducting an observational study, is something called inter-rater reliability or inter-observer reliability. Okay, and this is when one test is given to the same sample at one time, and two independent scorers or two independent observers calculate a score. Okay, so we primarily use this procedure or this test of reliability when whatever we're attempting to measure is inherently subjective. Okay, so what we would do in this case is we would again calculate a correlation, but this time we would calculate a correlation between the scores given by our first observer and the scores given by our second observer, right? And our fundamental assumption is that if the first observer gives a high score on whatever index we're measuring, then the second scorer should also give a high score if their scores are reliable or consistent. We could also look at the percent of agreement. So what percentage of the time did scorers produce the same score? Okay? Okay, so I'll give you a couple of examples. So whenever we look at, or whenever we utilize inter-observer or inter-rater reliability, one of the most important things we want to do is have a very, very clear operational definition, right? So a very precise definition of what you want the observer to assess. And you also want to give your observer a lot of experience measuring or scoring whatever your construct is. Okay, so for example, suppose I wanted two different teachers, Bob and Mary, to grade a student's essay about squirrels, right? So in fact, this is actually what happens with the AP exam is they hire a lot of usually people with master's degrees or PhDs in that subject. And all of these different teachers will score, or a group of different teachers or different individual experts will score someone's essay response on the AP exam, and they will look at the reliability or consistency of those scores. Okay, so when you're training your teacher or your scorer, you want to be careful to stipulate, for example, what topics should be included in the essay, right? So for an essay about squirrels, maybe your rubric says, I want them to talk about what squirrels eat. I want you to talk about how squirrels mate and who their predators are and how they build their nest and so on, right? So now your observer is going to know what components have to be present in order to get a high score on the essay. Okay. Similarly, suppose Bob and Mary are art experts and they're being asked to assess the merit of a painting, right? Then you would have to be very precise or operational in your definition of artistic merit, right? So that might include use of color, shading, proper style, realism, these kinds of dimensions that would go into whether you receive a high score or a low score. Okay. Okay. Another example that is actually used in psychology is if we were looking at, we were trying to measure how aggressive Jack's behavior was, right? We would have to indicate to our observers what constitutes aggression, right? So would a behavior only be considered aggressive if there was some kind of physical contact? And if so, what sort of contact? And also, would verbal threats count as aggression, right? So ideally, you would come up with some kind of score system, right? Where a light touch, like a nudge, would give 1 point, whereas a bite or drawing blood would give 200 points, right? And then your observers would simply sum up the score. So you want to make sure that you've made your scoring instrument as objective as possible to yield consistency in your scores between observers. All right, guys, so just in these last few minutes, I just wanted to give you a brief review of reliability because I know this was a lot of information. So of course, reliability is simply assessing the consistency of your measure, right? But depending upon the type of test that you have or what your specific goals are, that can take many forms. So let's go ahead and look at each of the types of reliability we've talked about today and kind of review what this test is examining, how you would execute that test, and also how you would interpret the results of that test. So first we have test-retest reliability, and essentially what that test gives us, or what information that test assesses, is it gives us a measure of stability, right? It tells us whether our test is stable or not over time, right? So if we wanted to use test-retest reliability, we would administer a single test at 2 different times to the same group of participants. And then when we're ready to look at our results, we would assess whether there is a strong correlation between the results we obtain the first time we administer the test and the results we obtain the second time we administer the test, right? So test-retest tells us whether our test or our measurement instrument is stable over time. Parallel forms reliability, okay, provides a measure of equivalence when we have 2 different versions of the same test, okay? So it provides a measure of equivalence when we have 2 different versions of the same test. And the way that we would execute a parallel forms test of reliability is we would administer 2 different forms of the same test to the same group of people and attempt to correlate the individual respondents' score on the first form of the test with their score on the second form of the test, okay? Next, we have inter-rater reliability, okay? And we would only use this test of reliability when we have multiple people scoring our test, okay? So because we're looking at multiple observers who are scoring the same test, inter-rater reliability provides a measure of agreement, okay? So the way that we would execute that is we have 2 different observers who rate behaviors or examine our test, and then we determine the amount of agreement between our observers, okay? So we have 2 different people scoring an essay. We have 2 different people determining whether a specific behavior is aggressive or not, etc. And what we want to determine is whether our observers agree with each other or whether their scores, their individual scores, are consistent, okay? So we can look at the percentage of agreements or the percentage of time that the scores are the same, or we can also simply correlate the scores provided by one observer with the scores provided by the second observer. Okay? And lastly, we have internal consistency. And internal consistency is used when we want to evaluate whether the test item that we've created, okay, features questions that are all measuring the same underlying construct, okay? So it provides a measure of how consistently each item or each question measures the same underlying construct, okay? So to evaluate that, we correlate performance on each item with overall performance across participants, okay? So we correlate the extent to which with Chromebox Alpha, okay, the extent to which our respondents' answers, okay, correlate with each other, okay, and with split half reliability, we are looking at whether the first half of our respondents' answers correlate with the answers provided in the second half of the test. Okay? All right, so I know this is already at 50 minutes, so I will stop here. But if you have any questions at all about reliability, please don't hesitate to contact me. And I look forward to chatting with you guys soon.